In this video we're going to look at how to calculate the number of milligrams of a compound that we need to weigh out to make up a buffer or solution. So let's say we have a buffer or solution with the following recipe. As you can see, this buffer consists of 6 different compounds, and we need to weigh each one of those out to make up this solution. Now, from the question we need to note a few key points. First of all, that the volume required is 0.6 of a litre, that we've been asked to weigh out the iron sulfate, and that the concentration of iron sulfate is 10 micromolar. We also need to note the molecular weight of iron sulfate, which is 278.01 grams per mole. And finally, we need to note that the answer has to be in milligrams to 2 decimal places. So how do we go about doing this type of calculation? Well, there's 2 approaches we can take. We can adopt a sort of walk-through reasoning type approach, or we can use a series of equations. So first, let's look at the walk-through reasoning type of approach. Now, the concentration of the iron sulfate is 10 micromolar. And that is effectively 10 divided by 1000 divided by 1000 molar, because 10 micromolar is the same as 10 times 10 to the minus 6 molar. So this means that 10 micromolar is in fact 0.00001 molar. Now, in the solution we're trying to make up, we've got 0.6 of a litre, and it's this 0.6 of a litre which will contain this 0.00001 molar of iron sulfate. Now, if we had 1 litre of this solution, we would in fact have 0.00001 moles. But as we've got 0.6, all we have to do is take this number of moles and multiply it by the volume, which is 0.6, and this gives us the number of moles present in the 0.6 of a litre, which is 0.000006. So that should be 0. Then 5 zeros and then 6 moles. Next, we need to convert these number of moles to grams, or in this case milligrams. Now, we know the molecular weight of the compound is 278.01 grams per mole. So to convert our number of moles to a weight, we just need to take the molecular weight and multiply it by the number of moles, and this gives us an answer of 0.001668606 grams. To convert this grams to milligrams, remember there are 1000 milligrams in a gram, we just need to take this 0.001668606, multiply it by 1000, and this gives us an answer of 1.66806 milligrams. And as you will recall, the question asks for the answer to 2 decimal places, so when we round this to 2 decimal places we get a value of 1.67 milligrams. Now, the other approach we can take is to use a series of equations. The 10 micromolar we can express as 10 times 10 to the minus 6 molar, and we know that the molecular weight is equal to 278.01 grams per mole. The equation for molarity is equal to number of moles per litre. We know that the molarity is 10 times 10 to the minus 6, so we can put that in. So 10 times 10 to the minus 6 is equal to the number of moles divided by the volume, which is 0.6. Rearranging, this gives us moles is equal to 10 times 10 to the minus 6 times 0.6, which is equal to 6 times 10 to the minus 6 moles. Now, moles is equal to the number of grams divided by the molecular weight. We know that the moles is 6 times 10 to the minus 6 is equal to grams divided by the molecular weight of 278.01. Rearranging for grams, this gives us an answer of 6 times 10 to the minus 6 times 278.01, which is equal to 0.00166,806 grams. Again, we multiply that by 1,000 to give us the number of milligrams. Rounding it to 2 decimal places gives us a value of 1.67 milligrams. And that's it. That's how we work out the number of milligrams of iron sulfate we need to weigh out to make up this solution.